Alright, this is Mr. Anderson for Kellogg Community College doing the third of 5 videos for Chapter 3, Section 4, using trig identities to solve equations and to get, actually not solve equations, we're going to establish identities using trigonometric functions. So on the left hand side here we've got 9 secant squared theta minus 5 tangent squared theta, and we have to get this equal to 5 plus 4 secant squared theta. So we're working with the equation with this on the left-hand side. One of our tactics is that if we're kind of stuck, you may want to try to turn this into sine and cosine. So I will do that by turning the 9 secant squared theta into 9 over cosine squared theta, because the cosine and secant are reciprocal functions. Also, I'm going to go with this minus 5 tangent squared theta. Let's make that sine squared theta over cosine squared theta. And what's kind of neat about that is now we have common denominators. So we're going to have 9 minus 5 sine squared theta over cosine squared theta. We know that sine squared theta can be rewritten, and I'm going to rewrite my sine squared theta as an equivalent expression with 1 minus cosine squared theta. And this is derived from our sine squared theta plus cosine squared theta equals 1. And what this is going to allow me to do is some kind of cool simplification here, because if I distribute this negative 5 into the mix here, I now have 9 minus 5 plus 5 cosine squared theta all over cosine squared theta. Now what's neat about that is I seem to have like some of this kind of taking shape here. 9 minus 5 is 4 plus 5 cosine squared theta. Now I can, since this is all being divided by cosine squared theta, I can put this all under, or cosine squared theta under all of these. And now you really see things take shape, because 1 over cosine squared theta is the same thing as secant. So this becomes 4 secant squared theta. And cosine squared theta divided by cosine squared theta is 1. And if I use the commutative property, I can write this in the opposite order. And I have now proven and I just established my identity that 9 secant squared theta minus 5 tangent squared theta is equal to 5 plus 4 secant squared theta. And the reason for doing all these is to try to, just kind of like move your brain muscles to try to see how you can manipulate some of these interesting functions. And number 12, I gotta admit, it stumped me for a little bit, because what I wanted to do is get common denominators, but in fact there's a more elegant solution, if you feel this is elegant, is the denominator is 1 minus cosine theta. So one of the tricks is when you see a 1 minus cosine theta, try multiplying the top and bottom by the same function, or this very well timed 1. And this multiplying top and bottom, this fraction over here, by that, what that's going to give me is a new denominator and also a new numerator. So this gets distributed to sine squared theta times 1 is sine squared theta, plus sine squared theta times cosine theta. And you're going to see that there's something kind of neat that happens here. All over, let's see, this is 1 minus cosine squared theta. Now what's neat about that is this bottom two binomials foiled to make this difference of squares. 1 times 1 is 1, and then we have minus cosine plus cosine, which simplifies to 0, and then we have this negative cosine squared theta. Now again, we're still going to work with just this fraction over here, but I'm going to rewrite it as 1 minus this entire thing over here to the right. So our denominator of 1 minus cosine squared theta can be rewritten as sine squared theta. So we can rewrite our entire problem, this numerator here, as sine squared theta. And then what we have here is, hold on. Let me pick up where I left off here. We got 1 minus sine squared, and this is, we're going to take our entire numerator here, sine squared theta, cosine squared theta, and since our denominator here is sine squared theta, we can just rewrite this as sine squared theta, and blam, we've got 1 minus 1 here. That's actually looking pretty good, and blam, we got this here, we got that simplifying. So now what we have left is cosine of theta, but there's got to be one little thing here, one little thing I'm missing, because when I did my distribution here, this entire thing has to be within inside a parentheses. So take a look at this. Take a look at this. I forgot that this whole fraction has to be subtracted. So if I distribute that negative, it's 1 minus cosine of theta. And that's how I get down to negative cosine of theta. So sorry, the phone call threw me off there. There was a big edit, but that now gives me what I need for problem 12. Okay, so let's go to problem 13. All right, so here we go with problem 13 here. I'm going to try to figure out how to get this left-hand side to look like the right-hand side. And it looks like I've got this sine of v on the right-hand side, so cosecant is the reciprocal of sine of v, so maybe this is going to get me in the right direction. So I'm just going to rewrite cosecant as 1 over sine of v, and I'm going to do the same thing over here. So 1 over sine of v plus 1. Now what do I do? Well, I think what I'm going to do is try to get a common denominator between this and this. So I'm going to multiply this fraction by sine v over sine v. This is multiplying by 1, which is a legal function. And this is sine v and sine v again. Okay, so now what we'll do is we've got 1 minus sine of v over sine of v. And then here we have 1 plus sine of v over sine of v. And we can divide two fractions, but instead of dividing two fractions, we'll just skip, flip, and multiply. So we're going to skip this first fraction, flip the second fraction, and multiply them around. So this gets looped up to the top, so this is sine of v over 1 plus sine of v. Now look at what we're trying to get here. This is going to work out nicely. These cross simplify to make 1, so now I have 1 minus sine of v over 1 plus sine of v, and we've established the identity there. Okay, so for problem number 14, again, these look really close here, but maybe I should take my cosecant theta minus 1 in the numerator. I got a cotangent theta down here. I'm going to multiply top and bottom by cosecant theta plus 1 and cosecant theta plus 1. Now what we'll do is we'll do some distribution here, and this is going to make cosecant squared of theta, and then you're going to have minus 1. Now the reason why is because this would give you plus cosecant and then minus cosecant, and that simplifies to 0. And in the denominator what we have here is we have cotangent theta times cosecant theta plus 1. Now you're probably saying, well, I'll just distribute this cotangent in there, but look at my answer, look at my target. I already have that right there, so I can transform that into cotangent squared theta over cotangent theta, and then cosecant c theta plus 1. And blam blam, then we have one cotangent left in the numerator, and then in the denominator we have cosecant theta plus 1. Hey, we just established our fourth of 5 identities, and now we're on to number 5. Number 5, and we'll wrap up this video here. And you can see that, well, how are we going to do this? It looks like we have secant over here and cosine over here. Well, like we did back in problem number 13, we're going to be doing some of the similar work here. We're going to turn this into 1 over secant theta plus 1, and this is going to be 1 over secant theta minus 1. You're going to see that this matches number 13 quite a lot. We're going to get common denominators here by multiplying top and bottom by secant of theta. So that's a very particular one. Same thing here, secant theta. Okay, so what we have here is 1 plus secant theta over secant theta. Because there's our common denominator, we combine those, and we have 1 minus secant theta over secant theta. And if you're a 121 student of mine, I want to kind of remind you that this is a multi-level fraction problem, and one of my techniques is if you look at the second and the fourth level of these problems, if they're exactly the same, then kind of a shortcut step, we can kind of move the top, the first and the third level over each other, because you can see that they are going to simplify to make 1 like they did back in problem 13, and we have our identity established. All right, well, thank you for watching. We got 3 down, 2 more to go, and they're doozies, so thank you for staying tuned, and we'll get to them.